Here's the first question, T7A09. What is the function of the single sideband slash CW slash FM switch on a VHF power amplifier? All right. If you buy a VHF amplifier or a UHF amplifier, very likely will have such a switch. Its purpose is to set the proper mode for the sideband slash CW. When we talked earlier about duty cycle, single sideband is only about 20 to 40 or 50% duty cycle. CW, it depends on how fast you go, but if you key down and hold it down, it's 100%. And all the time that an FM or AM transmitter is on, it is always transmitting maximum power. Now, you say, how can that be? Well, in an FM signal, we don't change the power output for the to carry the audio. We change the frequency, so its output's constant. In an AM signal, we change the amplitude of the sidebands, but we keep a carrier wave down the middle of it that's always at full amplitude. So think of it that way. It's a good way, a good concept to understand why we have to have different settings. Okay, there's a little more to that than that. There's filters they sometimes include a little different and so on, but that's a fundamental reason. T7A10, I'm not going to read off the numbers all the time. What device increases a transmitter output power from a transceiver? And that would be an RF power amplifier. Seems pretty obvious. Where is an RF preamplifier installed? And that will always be between the antenna and the receiver. Preamp takes the signal coming from the antenna, which might be just it's very little low voltage milliamp or microamp signal, and it amplifies it. Also keep in mind, while that improves your reception of the signal, it also amplifies everything else that the antenna receives, including noise. What can you do if you're told your FM handheld or mobile transmitter is over deviating? Over deviating is caused because you've got way too much or too strong of audio. So here are the things you can do. If it has an adjustment to adjust the audio input, you can reduce it. The proper way to make sure of all this is to put this on a scope and a spectrum analyzer or a standard deviation meter and to precision adjust it. But generally, you just back off on the microphone a little bit or talk a little softer. What's happening is your voice is so loud and your audio is so domineering that it's pushing the bandwidth of your signal outside of the receiver's range at the other side, at the other station. What would cause an AM or FM signal to receive an amateur transmission unintentionally? Well, generally speaking, it's because consumer receivers are made piss poor. They don't care about making them top quality receivers for the consumer. So it's the receiver is unable to reject strong signals outside of the AM or FM band. That would be a very likely possibility. The rest of these don't apply. Now, the front ends on consumer electronics receivers, televisions, AM, FM receivers, are nowhere near either as sensitive, nor do they have the ability to reject as well as ham radio receivers. Which of the following can cause radio frequency interference? And here the answers are fundamental overload, harmonics, spurious emissions, or all of the above. Fundamental overload is the front end of the receiver is getting a signal too strong, too nearby for the receiver to reject. Harmonics are uh, harmonic frequencies generated wherever the transmitter is that's transmitting. And spurious emissions are emissions that aren't filtered out from the original transmitter. And all of the above is the correct answer. Is that obvious why or not? Which of the following could you use to cure distorted audio caused by RF currents on the shield of a microphone cable? Well, a microphone cable is audio level. RF chokes will are designed to eliminate or reduce the flow through a conductor of RF signals. And if you've got an RF signal on your audio cable, a ferrite choke, which is an RF choke, would probably solve the problem. Not always, but most of the time. How can grounding also might help? How can fundamental overload of an amateur radio or TV receiver by an amateur radio signal be reduced or eliminated? Well, the answer there is block the amateur signal that's offending with a filter. And on the input, it'd be either receiver. And you got your choice. You might do it with a bandpass filter if it's appropriate, or you might have to do it with a notch filter to notch out one frequency. But nevertheless, you would block that signal. Which of the following actions? I got to ask a question on the break. Which of the following actions should you take if a neighbor tells you that your station's transmissions are interfering with their radio or television reception? First, make darn certain that your radio and your station is not transmitting out of band. It doesn't have spurs. For this reason, amateur radio operators should have some basic test equipment. Now, if you don't know this and don't have the test equipment, get a ham who does to come over with it. Okay? So make sure your station is properly functioning and that it doesn't interfere with this station when you're tuned to the same channel on another radio. From there, I'm going to give some advice. Be diplomatic. You can sit there till you're blue in the face and say to your neighbor, look, this radio's been tested. I've tested the environment. It's not my radio. It's your receiver on your TV or AM, FM radio. If they don't want to believe you, they're not going to believe you. And it's not worth a great big fight. So what a lot of hams have learned to do and used to do in the past, this isn't much of a problem since cable TV came in, but cable and satellite really is a blessing to us hams. What you can do is a lot of hams, we used to keep low pass and high pass filters handy. Television frequencies are going to be, well, generally they're going to be above 2 meter and 440 frequencies. So you want a filter that will pass everything until you get to, say, 400 and, well, modern TV, about 460 megahertz. 440 or 450 is the end of our 440 band. But if you're operating, say, on 2 meters and you're interfering with their FM or AM station, you want something that's going to block somewhere just below the 2 meter band and pass above 2 meters. And you want to, a lot of hams just go over and put it on their radios, put it on the antenna input to their radio if you can, or their TV. Today's world, it's not as common to have to do that. Okay, but the answer is A, make sure your station's operating correctly. If your station is within FCC standards, you will not be responsible if they're receiving you. If it's not, oh, you don't want to go to the FCC and be the one that's got egg on their face. They don't like being bothered anyway. Which of the following can reduce overload to a VHF transceiver by a nearby commercial FM station? And that would be installing a band reject filter. Now, a band reject filter could be a high pass filter. It could be but what they're really talking about is a notch filter that's notching for an entire band. Doesn't matter. The idea is that you can reject a signal with a filter. What should you do if something in a neighbor's home is causing harmful interference to your station? Well, reading all these answers, every single one of them is a good idea. Work with your neighbor to identify whatever is causing the interference. Politely inform your neighbors that the FCC prohibits the use of devices that can cause interference. And make sure your station makes good amateur standards. So all of the above are correct. That's a great general answer. It's the one that passes the test. In the real world, use common sense again. What should be the first step to resolve non-fiber optic cable TV interference caused by your amateur radio station? And D, be sure all TV feed lines or feed line coaxial cables are connected and installed properly. They just say installed properly. The connectors are installed properly. The fact is, if you're getting interference from a cable company, it's leaking somewhere, and usually there's a connector not tight. Cable stations transmit on every radio frequency at once. They got every channel you tune to is on another part of the RF spectrum. They don't transmit it out over the air because they're not handing it out on an antenna. They're feeding it directly into the receiver of a radio, which is a TV. TV receiver is actually a radio. And they are using what's commonly referred to as a closed system. It's supposed to be closed. There are commercial processes that use something called leaky coax. They actually have systems designed so that coaxes have holes in them to intentionally leak a signal out. This is not TV, of course. This is usually for data purposes, for controlling devices that are in motion. And along the way, such a weak signal is leaked out that a nearby receiver, inches away from the coax, gets a very, very faint signal giving instructions. So it's the opposite. It's being done intentionally, but it's the same net effect. What might be a problem if you receive a report that your audio signal through an FM repeater is distorted and unintelligible? Well, number one, if you're off by 5 megahertz, they'll hear you. You'll be distorted. If your batteries are running low, and on lithium batteries, this will not happen. But on all other types of batteries, well, you'll start to get distorted as the voltage is a little too low for your transmitter in your handheld. You're in you're in a bad location. Yeah, absolutely. If you're someplace where your signal is marginal, particularly in digital, it'll become extremely distorted. What are the symptoms of RF feedback in a transmitter or transceiver? Well, you'll stop. Answer C, reports of garbled, distorted, and unintelligible voice transmissions. Yeah, with feedback, it becomes garbled, distorted. That's a great description. So, um, sometimes that feedback is because of cabling. So that's why you want your audio and your RF cables all shielded wherever possible. Sometimes you don't want to run them too closely together with each other. Oh, let me see. Okay. What is the primary purpose of a dummy load? Well, that's obvious. It's the device to plug any one of your children into. No, that's of course not obvious. A dummy load is a 50 ohm for the most part, for most RF uh, transmitters ham radio operators use. It's a 50 ohm non-inductive resistor rated for a high enough wattage to be able to handle the entire power of the transmitter. I'm going to take a second to cover a couple of things about this. When you buy a dummy load, the purpose of a dummy load is A, to prevent transmitting signals from going out over the air. Instead of going out to an antenna, you're sending it to a resistor and converting all that power to heat. Remember that. You're converting it to heat, so it won't go anywhere. That resistor is supposed to prevent it from going anywhere by making heat. Well, it gets pretty hard to get a 1500-watt resistor. So we have things like cooling systems to aid us. So some dummy loads have fans and heat sinks that draw the heat away. Some are immersed in oils that draw the heat away. And some rely on the fact that you're not supposed to transmit into them very long. And they will be so rated on the instruction sheets when you buy a dummy load, or you can look it up online. So if you buy a dummy load and you're going to transmit into one, find out what its maximum frequency or maximum power level is. Find out what the maximum frequency it can handle is. And you also want to know what duty cycle it can handle. Some of them are relatively short. Yeah, they'll do 1500 watts, but only for a matter of 10 or 20 seconds. Some of them will handle 1500 watts for almost forever, but they're rather big, bulky, and they have tremendous cooling systems. Of course, if you're only running a few watts or milliwatts into it, you might not have a problem at all. Which of the following is used to determine if an antenna is resonant at a desired operating frequency? And a tool that they are recommending, and I will recommend that is a great tool to have, is an antenna analyzer. Antenna analyzer will tell you what the resonant frequency of an antenna is. It will also tell you a lot of other things about an antenna. There are other devices that can do this, but nothing does it as good as an antenna analyzer. We had to use some really backwoods ways of doing it. Uh, uh, a volt, a VTVM, which is a type of multimeter, it won't help you because that's a DC device. A Q meter measures the quality of a circuit. It will not help you. And a frequency counter won't help you, but an antenna analyzer will. What does a dummy load consist of? I think I've already told you. It's a 50 ohm non-inductive resistor, but it doesn't have to be 50 ohms. So that's why that's not the right answer. It's not used to terminate a resistance. That's also not why it's the right answer. Or to terminate a transmission line. It's used as a non-inductive resistor mounted on a heat sink. Well, that would be one of the types of dummy loads. I already told you it's either cooled with a heat sink, maybe with a heat sink and a fan, or it has uh, a liquid oil cooling. By the way, liquid oil nowadays usually is mineral oil because the old transformer oil is really bad for you. It's extremely carcinogenic. So if you see somebody with a wet dummy load for sale, make sure that you don't buy one that's got old transformer oil in it from way back in the day, because it's a hazardous waste material and you're going to play havoc trying to get rid of it. Uh, what reading on SWR meter indicates a perfect impedance match between the antenna and the feed line? The answer they give you is 1-to-1. A 1-to-1 SWR would be ideally perfect. In the real world, you'll never get a 1-to-1. You'll get a 1 to 1.01 at the closest. But for most of us, that's a 1-to-1. Okay? So if you have a digital display and it won't go lower than 1 to 1.01, even if it's 1 to 1.05, 1 to 1.1, those are good ranges. Okay? Why do most solid state transmitters reduce output power as the SWR increases beyond a certain level? The answer is A, to protect the output amplifier transistors. Every transmitter, modern transmitters, has an output amplifier section. Now, external amplifiers are just bigger of the same. But no matter what, those transistors, they can only take so much reverse current and you'll damage them. So they protect themselves by reducing the output power. There's a circuit that samples the SWR inside. And if the SWR is too high, it will reduce output power. And if it's really too high, you won't output at all. What does the SWR reading of 4-to-1 indicate? And 4-to-1 is a pretty high impedance mismatch. Your transmitter probably won't transmit at 4-to-1. Old tube types might, because you can tune the output to make it match at 4-to-1, but you won't on solid state radios. What happens to power lost in a feed line? Power lost in a feed line is converted into heat and it's gone. So it's dissipated out and it's gone. If you got too much power lost in your feed line, you're not going to get anything out the other end. So if you have long runs of feed line, I hope I said feed line, then you have to start considering feed line loss, and it's rated for every type of feed line. You can look it up from the manufacturers. You can find them online all the time. You can Google this and find it in an instant. And you want to find something that will not cause too much of a feed line loss. Feed line is presented as ohms per 100 feet. Which instrument can be used to determine SWR? Well, SWR is a measure of the forward and the reverse power. Power is measured in watts. Forward and reverse are two different directions. So D now becomes a very obvious question or answer, doesn't it? Which of the following causes failure of coaxial cables? The number one failure of coaxial cables is water, moisture in the cable. That's why it's important not to get nicks or cuts in the jacket, to use the silicon sealer or dum-dum as they call it around the connectors to keep moisture out of the coax. Why should the outer jacket of a coaxial cable be resistant to ultraviolet light? Well, if you're leaving your coaxial cable outside, you want one rated for UV exposure, because most of them are made of PVC. Standard PVC breaks down in high exposure to UV light. There's this big giant orb in the sky. I don't know where it comes from, but it's up there every day. It goes away at night, but during the daytime, it's presenting a lot of UV down on your coax. And I don't have to tell you how things fade because of it. And that's a pretty good indication of how much there is. What is the disadvantage of an air coaxial cable compared to a foam or solid dielectric types? First of all, the advantage of air is air coaxial. Usually they're hard lines, but not always. Sometimes they're regular coax and they have a spiral holding the center conductor from the shield, and it's filled with air or gas. Gas ones are pretty expensive and complicated, and we hams generally can't afford them. But what that does is it gives you a very, very efficient isolation between the ground and the conductor. But the disadvantage is you got to be super careful not to get moisture into it. And you got to be careful not to crush it, bend it too hard. You should always try not to bend any coax in a tight arc. If you need a tight right angle or even uh, I would say anything less than about a 9 or 10 inch like curved bend, then you should cut the coax at that point and put a right angle connector in there. You're better with a right angle connector than you are with a crushed coax. And like all coaxes, you want to keep moisture out. But in order to keep moisture out of the air dielectric conductor or coaxes, even hard lines made that way, there are special sealers techniques and the ways you keep the humidity out of them to begin with, because there's nothing there but air. And if you fill that air with moisture, you're basically going to be shorting out all the time. Using basic test instruments, voltmeter, ammeter, ohm meters, and soldering. Which instrument would you use to measure the electric potential? Electric potential, or electromagnetic force, or electromagnetic potential? All the same thing. We measure it in volts. So we need B, a voltmeter. Okay. How is a voltmeter connected to the components to measure the applied voltage? Voltmeters are always applied in parallel to the voltage we want to measure. If we're measuring across a resistor, we're going to be measuring the voltage across that resistor. If we're measuring across a battery, we want to measure the voltage across that battery, and it's going to be a parallel connection. When configured to measure current, how is a multimeter connected to a component? Current is a flow through a component. So you have to be in series. In order to measure current, you have to open the circuit and put the the amp meter in between the component and the rest of the circuit. Sometimes that's a challenge. So in solid state circuits, sometimes that means you'll have to unsolder one leg of a chip or one leg of a component and measure in between the one leg you freed up and the circuit board pad that it was once connected to. Then when you're done, you have to reconnect it. Which instrument is used to measure electric current? Now, what is current? Current is flow of electrons. When we measure it, and it has a unit called amps. So a meter that measures amps must be an amp meter. D would be the correct answer. Right back to the class. I'm going to share the questions and answers again. T7D06, which of the following can damage a multimeter? And the answer is C. Attempting to measure voltage using the resistance setting. You can also damage them by trying to read too much or too high of a voltage because it's greater than its range, or too high of a current because it's greater than its range. But one that will damage a meter almost guaranteed is if you have it set in the resistance range, which is designed so that there's an internal battery in the meter and it provides a voltage of maybe 6 to 9 volts. And then when you feed that through the circuit, that 6 to 9 volts then comes back and moves the meter movement proportionate to the resistance. That's what we get. That's how we measure resistance. If you add even more voltage, if you hook that up to 110, you're going to fry that meter. Now, some meters have protection against that, but you got to pay through the nose to get that protection. It's very expensive meters have protection from that. The cost difference is sufficient that after you make that mistake one time, it'll be cheaper to buy a new one, which you'll have to do. And then it will to have bought one of the ones that won't let you do that, that won't destroy itself. Oh, which of the following measurements is made using a multimeter? A multimeter generally can measure voltage, resistance, and current. Some have capacitance meters added in or inductive meters in, but most do not. That's a very rare thing. And none of them measure signal strength as a rule. I don't know of any. The three things that a multimeter by definition is supposed to have is voltage, current, and resistance. Anything else, some manufacturer has given you more than a multimeter. Which of the following types of solder should not be used for radio and electronic applications? First, let's go through them. Acid core solder is designed for soldering metals together. The acid would damage the components in a radio circuit. Lead tin solder was once used in amateur radio. It's fallen out of favor for leadless solder, but it's still usable today. Okay. Rosin core solder is the solder you should use. And tin copper solder, I don't know that it would do any harm, but it would be really tough to work with. Okay. But acid core solder will out and out damage components. It's corrosive. While you're soldering it, the bubbling acid would eat up the electronic semiconductor components. So do not use acid core solders. They're designed to etch into steel. What is the characteristics of an appearance of a cold? What is the characteristic appearance of a cold tin lead solder joint? If you have a solder joint that looks dull, rough, and lumpy, that's a cold solder joint. A good solder joint will be bright and shiny, look polished, okay, and smooth. The way you get a good solder joint is you make sure the solder flows through the component. And you'll be able to observe the flow with a little practice with a soldering learning kit. You can get real good at it fast. What is the reading that indicates that an ohm meter is connected across a large discharge capacitor? Well, if you look up to a large capacitor that's charged, you're going to pretty much damage that meter. But if it's discharged, when you first take a measurement, you're going to have a low resistance. And as the voltmeter keeps pumping voltage into that capacitor, you're going to charge that capacitor. And as it gets charged, its resistance is going to appear to increase. Slowly, it gets more and more and more resistance on the meter. It's a good sign that you're across a charged capacitor. How do you prevent? How do you guess you would prevent from measuring across a circuit that might have a capacitor that might be charged? Well, the easiest way would be to put your meter first on volt reading. See if there's a voltage presence. If there is a voltage present, then you should short out whatever capacitance is there. Usually short it out with a jumper cable and a resistor. Don't short it out dead short unless you know it's safe to do that. High value resistance resistor you put on a little jumper wire, and you jumper that in maybe with alligator clips or whatever will hold it. And you wait a little while, maybe go away, walk away, have a cup of coffee, come back, and now it should be discharged. Which of the following precautions should be taken when measuring in circuit resistance with an ohm meter? Ensure B, it is ensure that the circuit is not powered. Same reason I told you to take a voltmeter and check for a capacitor having a charge. That's powered. Checking a circuit with a voltmeter first is always the way to make sure a circuit is not energized or powered or doesn't have residual power. And so that's B is the right answer, and it's a practice you should always do. Okay, we're going to cover FM sideband, bandwidths, etc. I'm going to jump right into it. Which of the following is a form of amplitude modulation? Single sideband is an amplitude modulation. All of the others aren't. Spread spectrum is its own type of modulation. Packet radio is generally FM. And phase shift keying, phase is the key there, is FM. Single sideband is basically an AM signal which the one sideband and the carrier have been suppressed or removed. What type of modulation is commonly used for VHF packet radio transmissions? A is the answer. Remember I said your packet is generally FM. Well, phase modulation essentially is FM. It's the means by which they're generated that differs, but the signal is the same. The final result's the same. How you get there is what's different. Most modern FM radios are really phase modulated radios. Which type of voice mode is often used for long distance, weak signal contacts on the VHF and UHF bands? The answer there is C. Single sideband most efficiently carries information, your audio, over the frequencies because it has the narrowest bandwidth, so all the power is kind of squeezed into that narrow bandwidth. So it tends to punch out a little further. CW carries information on even narrower bandwidth, so it tends to punch out even further than that. But so that's pretty self-explanatory. Which type of modulation is commonly used for VHF and UHF repeaters? The answer is D. Again, FM or PM. Keep in mind, FM and PM are the same thing, phase modulated or frequency modulated. They just differ in how they're created. Which of the following types of signal has the narrowest bandwidth? Gosh, I think I gave this away. CW has the narrowest, and there's a chart here. This is in your book. I forgot what it is in your book. It's good to reference so you see how wide signals are. One thing I always try to tell everybody, take a look at fast scan video. That's live moving video, just like on the TV transmission, TV, broadcast TV. It is 6 megahertz wide. Guess why we don't have TV signals that we can transmit? We're not allowed to transmit TV signals down in the frequencies of the bands below 50 megahertz? Well, one reason might be because most of those bands themselves are only 3 or 4 or 5 megahertz wide. Now, we can fit a lot of CW signals where this single TV broadcast signal might be. In fact, we can put hundreds and hundreds and hundreds of phone communications in some fast scan TV signals. So keep those in mind. Which sideband is normally used for 10-meter FM, a VHF, and UHF sideband? As a rule, amateur radio operators decided years ago it became the international standard. Now it's the de facto law. It's just common law for all of us on ham radio. We decided that 40 megahertz is the cutoff. All CW transmissions are all sideband transmissions are to be transmitted on lower sideband, 40 megahertz and below. 40 meters and below, not megahertz. The 40-meter band is the cutoff. So the 40-meter band ends at 7.3 kilohertz and 7.3 megahertz. So 7.3 megahertz and below, we use lower sideband. Everything above it is on upper sideband. So the answer is A, upper sideband. As technicians, you'll probably only be using upper sideband because you don't have privileges for sideband below that. You will if you become generals. Which characteristics of single sideband, what is the characteristics of single sideband compared to FM? Well, single sidebands are not easier to tune. They're neither more or less susceptible to interference. Actually, there may be a little more, but they are narrower and much narrower. So a single sideband transmission is narrower, and as a result of that, it not only uses less bandwidth for allowing more stations on the bands at once, it gives you more punch or more range. What is the approximate bandwidth of a typical single sideband voice signal? And generally, it's around 2.8 kilohertz, but let's round that up, and 3 is approximately right. What is the approximate bandwidth of a VHF FM repeater? Now here's a comparison. Generally, we transmit on what we call wideband FM. It's not commercial full fidelity wideband FM, but it's communications wideband. And it is between 10 kilohertz and 15 kilohertz wide. Commercial broadcast is answer D. Now, there is also a commercial 500 kilohertz wide that's called narrow FM. The commercial, radio for taxis, police, etc., and some of the FM services like family radio and so on, those are narrow band. What is the approximate bandwidth of an AM fast scan TV transmission? And it's restricted to the same thing as AM, and that is B, 6 megahertz. What is the approximate bandwidth required to transmit a CW signal? Well, a signal on CW will transmit normally quite well on 150 hertz, not kilohertz, hertz. It's pretty darn narrow and very efficient. Which of the following is the disadvantage of FM compared to single sideband? B, only one signal can be received at a time. And I got to answer that one with an explanation. An FM detector has what's called the capture effect. It captures the strongest signal that it receives, locks into it, and rejects all the others. Remember that. We take advantage of this for something like voting receivers, where you have multiple receivers feeding into a repeater from different locations, so that when one person keys up close to one receiver, it only listens to that one receiver because that's the strongest one that got captured. We take advantage of this for a number of applications, but we have to keep it in mind. The commercial aviation industry always demands that their radios be AM. And pilots have to listen to a lot of noise on those AM frequencies. They could be a lot quieter if they were FM, because they would only hear the strongest signal and it would reject everything else. And so you can turn the squelch up quite a bit and eliminate all the background noise because it would be squelched out whenever nothing's transmitting. That's what we do on FM with our FM radios. But the FAA and radio or aircraft towers, they don't want to miss a weak signal in a disaster or emergency. If a plane's going down and his signal is weak, they don't want him not to be heard because a closer plane is got a stronger signal. On AM, you will hear weaker and stronger signals. You might not hear the weaker one as well, but you will hear it. And they kind of walk all over each other, but they don't eliminate each other. A confusing point is when two people try to transmit through an FM repeater at the same time. That repeater tries to retransmit them both together, and it really causes havoc. But that's not the general rule. That's because of the way repeaters retransmit. Okay, telemetry. This is satellite Doppler shift, things like that. I've covered it in your class. What telemetry information is typically transmitted by satellite beacons? And the answer is usually C, the health status of the satellite. That's its telemetry. I might include things like its location, but it generally is the health and status of the satellite. What is the impact of using excessive effective radiating power on a satellite uplink? Remember, I'm telling you that when you use this, I've told you, when you use the satellite, it shares all of its output evenly, or at least it hopes to, from all of its input. But if one of its input is way more powerful than the other, it gets disproportionate access. So if you overpower the satellite, you will be blocking everyone else from using frequencies that they normally could use. Because look at it this way: if the way the satellite works, if it's getting a 1,000-watt station coming into it, and it's getting a 5-watt station, well, it's going to send back proportionate to the 1,000-watt station. So the amount of power that little 5-watt station proportionately is going to get back. Well, let's look at it with numbers. Let's say that 1,000-watt station, the transmitter on the transponder of the satellite might only have 5 or 10 watts. So that 1,000-watt station is going to, its signal is going to go back with maybe 99% of that. So all the other users might only get 1% between them. It's not quite true. The numbers aren't exactly like that, but it's an idea of grasping the concept. The way that it retransmits a transponder on a satellite is very different than the way that a repeater operates. Which of the following are provided by satellite tracking programs? Okay. Satellite tracking programs usually show you a map of real-time positions of the satellite going over the Earth. It'll tell you the time, azimuth, and elevation of the start, minimum altitude, and the end of the pass of the satellite. It'll give you the approximate frequency of the satellite transmission. Remember, satellites are in motion, and as they're in motion, you have Doppler shift occurring. So they will normally tell you the effects of how much the shift is as it's passing closer to you and then further away. So all of these are correct answers. What mode of transmission is commonly used by amateur radio satellites? Well, the answer to that is tricky. We have satellites out there use just about every single mode there is. So it's so tricky that any that they would list would be right. So single sideband, FM, CW. I don't think the one that might be exception. I don't know of any fast scan TV, but just about all the others. What is a satellite beacon? And the answer here is a transmission from a satellite that contains status and information. All right, I want to talk about really quick to remind you. There are some common terms for satellites in here, right at the bottom of this page. I'm going to review them really quick. Satellites travel around the Earth usually in an elliptical pattern. The exception is geosynchronous. They're actually elliptical, but they coincide with the rotation of the Earth so that they're always in the same position in the sky. So a satellite's orbit has an apogee, which is its farthest point from the Earth, and a perigee, which is its closest point to the Earth. A beacon is the information that the satellite's telling you about itself, its condition, its health, and its status. Doppler shift is a shift in frequency caused by the relative motion between an object in motion and another object. In this case, you and me on the Earth and the satellite moving overhead. Elliptical orbit means that it's got a difference between a large difference. It's egg-shaped between apogee and perigee. Most amateur radio satellites are LEO satellites. That's low orbit satellites. They're relatively close to the planet. FCC's definition of a space station or operating in space is defined as an amateur station located more than 50 kilometers above the Earth's surface. And spin fading is a signal fade that's caused by the rotation of the satellite. As it spins, the antennas spin, and so they're not always facing at you. They get slightly attenuated by the spin as it spins. So it gets louder and softer because of the spin. Which of the following inputs to a satellite? Which are the following inputs to a satellite tracking program? Well, Kepler, a early mathematician and astronomer, figured out how to calculate orbits. So he divides the mathematics for it. We refer to them as Keplerian elements. The Keplerian elements are put into Kepler's formula. They're the required variables. And it tells you, it allows you to calculate out the motion of an orbiting body, in this case, satellites. So the thing you need to input, most important, into satellite tracking programs are Keplerian elements. Of course, the time of day is important. And so will be your location on the Earth. And from that, it can calculate everything else for you. What are Doppler shifts in reference to satellite communications? I've already covered this, but it would be C. An observed change in signal frequency caused by the relative motion between the satellite and the Earth station. What is meant by the statement that a satellite is operating in UV mode? And the answer here is B. We define UV as being uplink on 70 meters, downlink on 2 meters. I hope it has the chart. I'll find it. What causes spin fading of satellite signals? I've covered this just a minute ago. B, the rotation of satellite and its antennas. If you imagine the antenna spinning around the body of the satellite, sometimes the satellite in that spin is momentarily blocking the signal. Sometimes it's not. Sometimes the angle is towards you. Sometimes it's away. That sort of thing. What is an LEO satellite? Well, that's a low orbiting satellite. So that would be D. Who may receive telemetry from a space station? Anybody can listen to telemetry from a space station. Pretty much anybody can listen to anything on the amateur bands. Remember that. Don't say anything embarrassing. Which of the following is a way to determine whether your satellite uplink power is neither too low nor too high? C, your signal strength on the downlink should be about the same strength as the beacon. That's one of the advantages. Tune to the beacon, see how many S units the beacon is coming to you at. Yes, there will be fading in and out, but look for its maximum. And then tune to the frequency to listen to your own downlink. You can do that because there's a little delay between the time you transmit and time it comes back down. And you'll be able to see when you've got it about the right amount of power. It's real simple. Which of the, oh, and by the way, it's kind of cool to hear your own voice coming back after you've said it. Don't leave it on listening to it because it will drive you crazy when you're trying to talk, hearing your echo. Which of the following method is used to locate sources of noise or interference or jamming? Noise interference or jamming. And the answer here is radio direction finding. And there are various techniques of radio direction finding. Some ham clubs do fox hunting, which is to practice learning how to radio direction find. There are many tools for radio direction finding. Which of these items would be useful for finding a hidden or for a hidden transmitter HUD? A directional antenna allows you to rotate that antenna in the direction of the signal. So it would be very useful for direction finding. What operating activity involves contacting as many stations as possible during a specific period? That means during some interval of time. Well, the answer to that is contesting. That is what contesting is about. If it's a 24-hour contest, everybody participating for the most part is trying to make as many contacts in that 24 hours as possible. Which of the following is a good procedure when contacting another station in a radio contest? Well, because they're trying to go as fast as you can, you want to send C. Send only the minimum information needed for proper identification and the contest exchange. Contests themselves are organized by groups, and sometimes they have certain special rules. But generally, you want to make contacts and send your station ID, a signal report, and good luck, old man. Good luck in the contest, and you're done. And you don't. And the good luck, old man, in the contest is optional. By the way, old man or OM in amateur radio goes back to the early days in amateur radio. It's not an insult of age. It wasn't intended to be an insult of age. It was a recognition that you have old wisdom in radio, that you have the old man's wisdom of radio. It's a compliment. Don't get insulted by it. What is a grid locator? A grid locator is a number designated assigned to a geographic region. You can find grid maps on the net. You can find them published by the ARRL. You can find them around the world. Every bit of the earth that has land has a grid assigned number. and they cover a pretty fair size area. But if you look at a grid map, you'll see a state might only have 4 or 5 grids, but there are rectangular shapes that well, they're square actually, that represent uh, portions of the earth, and they're numbered with letter and number combinations. And they're unique for every part of the earth. How is over-the-air access to IRLP nodes accomplished? Yeah. The way you do it is with DTMF signals, which is dual tone, multi-frequency tones. We in North America don't usually do this, but in Europe and Asia, their repeaters key by two-tone DTMF signals. Um, and accessing their nodes is done by punching in a touch tone number, which is a dual tone signal. It's not as common in the United States. We do have some repeaters that allow access to unique uh, uh, things because of this through the nodes. We have digital repeaters that allow you to access nodes numerically using touchtone pads. They basically do it this way, but it's not that common. So if you get this IRLP, which is uh, inter radio, I forgot what it stands for, but anyway, it might be international radio. I forgot what the L stands for, protocol. Uh, you you use the touchtone keypad on your radio to access them. So now we use CT CSS tones to bring about our repeaters to activate them in many circumstances. That's a different thing. CT CSS is a sub-audio tone that's constantly transmitted while we're transmitting. It's constantly present in the background. The repeater hears that sub-audio tone and recognizes that it should key up and retransmit that station. The reason for that is to avoid interference. But, okay, I'll move on. What is voice over internet? That's what I couldn't think of. Voice over internet protocol. Voice over internet protocol is a method of delivering voice communications over the internet using digital techniques. And I'm sorry, that's what I couldn't remember, but that is a similar circumstance to the IR internet protocol. And so when we talk on digital radio, the technique for delivering that voice over the internet is voice over internet protocol. It's pretty simple. It's not rocket science, to put it mildly. What is the Internet Radio Linking Project? I'm pretty involved in it. It's what I was talking about before. IRA, that's what I couldn't think of. It's the Internet Linking Project. I drew a mental blank, guys. I apologize. I'm involved in this and I work with it every day. You'd think I could come up with this. I do apologize. It's a technique for interconnecting amateur radio systems via internet voice over the internet. So what we have done, if we've tied together repeaters and other amateur systems, so that we can use the internet to tie, say, one repeater to another repeater, or to give you home access to a repeater from a computer or even your cell phone. And by using those techniques, we can use the internet to tie a bunch of repeaters in cities all over the world together. So you can drive down the road in your hometown and be talking with a guy who's driving down the road in Hong Kong, talking on his local repeater. And the way it comes about is you take the touch home pad on the back of the microphone or on the front of your handheld, and using the right procedures, which is different for everyone, but you can find them. You just punch in the codes to put you on to linking to that repeater. It's pretty cool stuff. Right now in the state of Michigan, I have helped put together and I help maintain a system of, I believe we're up to 33 repeaters, and they cover from Sandusky, Ohio, which is below my state, all the way up to Sault Ste. Marie, which is way up in the upper peninsula of Michigan. And all the way in between, we have repeaters. Now, every zone, every mile in between has coverage. We're trying to get there. But pretty much if you drive down I-75 north and south, we have a repeater that covers all the way to those distances. Which of the following protocols ensures an amateur station to transmit through a repeater without using a radio to initiate transmission? Well, one of those one of those internet radio links is specifically designed to allow you to transmit without using a radio, and that one is called Echolink. From Echolink, any access to the internet can get you to the Echolink's website. On the Echolink website, you can punch in the repeater that's linked onto Echolink. You can bring up that repeater from a keyboard or touch screen on your device, and you can work that repeater from anywhere in the world. Well, there might be some foreign countries that will put you in jail for it, but generally you can. Which is required before using the Echolink system? Well, you first got to get permission and get training from Echolink. You got to purchase a license to use the Echolink software, but it's minuscule. And you've got to register your call sign and provide proof of your license. You go on their website, they walk you through all that. The fee is a donation to help maintain the system. It's minimal. But you do all those things and you've got Echolink access. Boom, you're done. From Echolink access, you can use any of the repeaters and any of the transceivers linked to Echolink, so long as the output of them does not occur in spectrum you're not privileged on your license to handle. Which is an amateur radio station? What is an amateur radio station that connects other amateur radio stations to the internet? And that is a gateway. Repeaters connect as a gateway, but technically the device that links you to the internet is a gateway from RF to the gateway, or through the gateway to the internet. Down here is a great explanation. Most common examples are APRS gateways and WinLink gateway stations. And you'll be familiar with them in no time playing with them if you get into digital radio. Okay, I'm to 8. I want to really get going because I got to get through a lot. Which of the following is a digital communications mode? All of those are digital communications. Packet, IEEE 802.1 is type protocol, and FT8. Those are all digital communications. And it kind of explains it right here. IEEE 802.11 is basically Wi-Fi. What is a talk group on a DMR repeater? B. It's a way for groups of users to share a channel at different times without hearing one another's. Now, if you're listening generally, you can hear everybody, but if you only want to hear guys in your group and then you get into a group. Now, some systems and most DMR systems require that you use a gateway. Some do not. What kind of data can be transmitted by APRS? Well, APRS will send your GPS position. It will allow text messages to be sent, and you can even receive and send weather data on an APR system. It's fairly automatic on some systems. So APRS radios generally have their own GPS. They have some way of detecting the weather conditions, and they share that when you transmit. So all of the above is correct. What type of transmission is indicated by the term NTSC? Let me make this easy. National Television um, System used to be corporation, but now it's committee. So NTSC is what we normally think of broadcast TV or analog fast scan television. So C is the correct answer. Which of the following is an application of APRS? Well, it provides real-time tactical digital communications in conjunction with a map showing the location of each station or every station. Now, that's not fully true. In some radios, you don't see a map because they don't have a display for an actual map. They don't have like a flat screen. Some radios, you will just get the location and or the distance from you and the next station transmitting, that sort of thing. But they will give you relative location data. So A is the correct answer. What does the abbreviation PSK mean? PSK stands for phase shift keying, and it is a very popular type of keyboard-to-keyboard communications. The most common is PSK 31, and it's probably going to change with a new ruling. Which of the following describes DMR? And it's a technique for multiplexing two digital voice signals on a single repeater channel. DMR was designed for general land mobile. We've carried it over into amateur radio, and we get the advantage that we really can multiplex two independent signals at the same time on a repeater. Of course, by using grouping, that way one won't interfere with the other one. Only the hams that are talking in one group will hear what one group's supposed to hear, and the other group will hear only what it's supposed to hear. Which of the following is included in packet transmissions? Okay, a packet starts with a header. Then there's a main body of information. There's a checksum that gets sent so they can detect errors at the other end, and the other end can send back a repeat request in case there's an error. All of the above are part of packet. That's the way packet works. You send your data, there's a header that gets built in the computer and interface. There's a checksum that it calculates out. It sends all that information, including what station it's coming from, where it's going to. The other end checks that checksum, looks to see if it's got everything that adds up right. If it doesn't, sends a request to reconnect or resend, I'm sorry. So all of the above is the answer. All right, what is CW? CW is continuous wave. All right, so it's another name for Morse code. D. Which of the following operating activities is supported by digital mode software in the WSJT suite? That's the suite is a package. It's an open source package software you can download online for free, by the way. It allows Earth to moon communications. It's set up to support weak signal beacons, and you can use it for meteor scatter. It is kind of the digital mode for all the fun stuff that's up in the sky. What is ARQ? What is an ARQ transmission system? It's an error correction system in which the receiving station detects errors and sends requests for retransmission, automatic retransmit request transmission system. So it's an automatic retransmit query transmission. So remember that. Packet is an example of something that uses ARQ. Which of the following best describes an amateur radio mesh network? Mesh network is a radio-based data network using commercial Wi-Fi gear and some modified software, well, actually firmware and software, to build our own amateur radio Wi-Fi system that covers a larger area. So way we can use Wi-Fi gear to make a giant Wi-Fi system for amateur to amateur communications. It's not a internet like system, it's a communication system. I'm going to get back to the class. I'm going to get through as many as we can today, guys. Do you guys have any objection if we run a little bit over? Tom, is that okay? Okay. So let's go ahead and I'll share the book, and we're just going to go as far as I get until I have to call it quits. Well, we've covered the material. Now we're just going over the questions and answers. So what is FT8? Well, FT8 is a digital mode that's capable of low signal to noise operation. FT8 can operate down in the noise. It doesn't have to be above it. All right, antennas. What is a beam antenna? A beam antenna is an antenna, answer C, that concentrates its signal in one direction. A bidirectional beam antenna does it in two. Which of the following is described as a type of antenna loading? And A, electrically lengthening by inserting an inductor in the radiating element is what antenna loading is defined as. It's a coil that gives you more inductance to electrically increase the length of the antenna. Which of the following describes a simple dipole oriented parallel to the Earth's surface? B, a horizontally polarized antenna paralyzed. I apologize. What is the disadvantage of the short, flexible antenna supplied with most handheld radio transceivers compared to a full-size quarter wave antenna? Well, we call those things rubber duckies, and they're glorified dummy loads that leak out a little signal. So they're very low in their efficiency. So a full-size quarter wave antenna will be far more efficient. The answer is A. The disadvantage is that rubber duckies are not very efficient. Which of the following increases the resonant frequency of a dipole antenna? You increase the resonancy of a resonant frequency, of a dipole antenna. If you're trying to make the frequency higher, then you need to shorten the antenna. If you're trying to make it lower, you need to lengthen it. In this case, we're trying to increase the resonant frequency of an antenna. We want to shorten it. Okay. Increasing a frequency is going higher. Which of the following types of antennas offers the greatest gain? A 5/8 wave vertical isotropic antenna, which is a dipole in space, essentially. C, a J-pole or a Yagi? Well, in a given direction, and it has the greatest gain would be a Yagi. It's a beam antenna with tremendous gain in the direction it's going. So beams will offer the greatest gain. Different beams will offer various improvements in gain. What is the disadvantage of using a handheld VHF transceiver with a flexible antenna inside the vehicle? Well, let me tell you guys, inside a vehicle, you're shielding that thing inside a giant Faraday cage. Faraday cages are intentionally built to stop radio signals from getting out. Cars are made of metal, which is what a Faraday cage is. You're wrapping it with a metal shield all the way around the antenna, and the only way you get out is through the windows in the vehicle. So the top and the front and most of the back isn't letting things through. So the answer is A. The strength is reduced because of the shield effect of the vehicle. What is the approximate length in inches of a quarter wavelength vertical antenna for 146 megahertz? Or that's the 2-meter band. For a quarter wavelength, you use a quarter wavelength frequency, 234 divided by the frequency. It's going to be approximately 19 inches. Answer C. What is the approximate length in inches of a half-wave 6-meter dipole? Okay, 6-meter dipole, we want a half-wave. The half-wave formula is 468 divided by the frequency in megahertz. So we take 468 divided by 50, and we get C, 112 inches. Okay? In what direction does a half-wave dipole antenna radiate the strongest? All right. It transmits weakest off the ends. It transmits strongest broadside to the antenna. What is antenna gain? It's an increase in signal strength in a specific direction compared to a reference antenna, which is usually an isotropic dipole. What is the advantage of a 5-way 8-inch whip for VHF or UHF mobile? It has more gain than a quarter wavelength because it's 5/8 of a wave. And that's the simple answer. Why? Well, because there's more antenna, and 5/8 is, again, resonant, just like a quarter wave. What is the benefit of low SWR? B. You got reduced loss signal because it's not being fed back a reverse power going back to the transmitter. It's more of it's going out to the field. What is the most common impedance of coaxial cables used in amateur radio? It's almost always 50 ohms. Why is coaxial cable the most common feed line for amateur radio systems? Because we're stupid, but no, the answer is A. It's easy to use and it doesn't require special installation. It has very few special installation considerations. What is the major function of an antenna tuner? It matches the antenna system impedance to the transmitter's output impedance. That's all it does. It doesn't improve the antenna. It doesn't create a better signal. It just matches the electromagnetic impedance of the transmitter to the impedance of the antenna, which is the load. And we'll skip that. That's a picture of how you hook one up. Antenna tuner goes in between the transmitter and the antenna. What happens as the frequency signals in a coax cable is increased? Well, if you increase the frequency going through a coax, its losses increase. Coaxes are rated by the frequency for loss. So when you see a frequency chart for coax, it will give it at various frequencies. So a coax that might work really well in the HF band might be miserable in VHF. And a coax that works really good in VHF might be miserable in the microwave region. Which of the following RF conductor types are most suitable for frequencies above 400 megahertz? And their answer here is B. And that's probably the best connector above 400 megahertz. But quite honestly, A is not a bad connector for the purpose. It's just not quite as good as the N connectors. Answer B. Which of the following is true of the PL259 type coax connectors? Well, they're probably the most commonly used for HF and VHF frequencies. Which of the following is the source of loss in coaxial feed lines? Well, okay, of all those answers, water. That's probably the, is it following as the source of loss? Well, high SWR would be loss. Multiple connectors in a feed line is minimum of a loss. Well, okay, learn this answer. The FCC expects you to say that water intrusion in a coaxial connector, I would reword that as probably the worst thing that can cause loss. So what can cause erratic changes in SWR? Well, thunderstorm doesn't do it, overmodulation doesn't do it, overload doesn't do it. What really does it is loose connector, feed line, or other problems in the feed line or the antenna. So a loose connector would be a good answer. What is the electrical difference between RG8 and RG213 coaxial cable? RG213 has less loss at any given frequency because of the way it's designed. It's more expensive, but it offers less loss. That's why it's more expensive. Which of the following types of feed line has the lowest loss of VHF or at VHF or UHF frequencies? Well, the answer to that is going to always be a hard line, and C, air insulated hard line, is the best of the feed lines you can get. What do we also know? It's also the one we have to do the most to make sure moisture and water doesn't get into it. What is standing wave ratio? SWR. It is a measure of how well a load is matched to the transmission line, and the way we measure that is by measuring the forward signal in comparison to the reflected signal. So it's an indication of match, not an indication of quality of the antenna. Keep that in mind. All right, we're getting to the stuff I need to get to. Hazard. Which of the following is a safety hazard of a 12-volt storage battery? Shorting the terminal can cause burns, fires, and explosions. That would be is the correct answer. Why don't you get shocked with a 12-volt battery? Because the resistance in your body is too great to permit it. What is a health hazard presented by electrical currents flowing through the body? The answer is every one of those. It can cause injury by heating tissue. It may disrupt the electrical functions of your cells, which includes your heart. It may cause involuntary muscle contraction, which includes your heart. All of the above are bad things to happen to your body. Don't let them happen. D is the answer here. And we'll move on. I covered this last week, or last session. In the United States, what circuit does the black wire insulation indicate on 3-wire 120-volt cable? The black is the hot in the United States. Sometimes it's red. Usually it's hot. The hot can be red, black, or blue, but it's usually black. And the white is a neutral. The green is a ground. Green is ground the world around. Never forget that. What is the purpose of a fuse in an electrical circuit? Well, a fuse is a metal that melts away and blows. And it does this to remove power in a case of a overload or short circuit. Why should a 5 amp fuse never be replaced with a 20 amp fuse? Because it won't blow fast enough, because it will let too much current going through. So the answer is C. Excessive current could cause a fire. Why? Because if the fuse doesn't heat up and burn up, maybe the wire will. And if the wire heats up and burns, that might be running all the way through your house. Don't do it. What is a good way to guard against electrical shock at your station? I'll use 3-wire cords and plugs for all AC equipment. Connect all AC equipment to common safety ground and install mechanical interlocks in high voltage circuits. All of these are good choices. Never defeat mechanical interlocks in high voltage circuits. They're there to protect you. And there are in some voltages, there is no test equipment that can measure those voltages. So there's no reason to have access to it. There are ways to test without entering the high voltage side. Where should a lightning arrestor be installed in the coaxial feed line? Should be outside of the house to begin with, near the AC power service panel point. You can put one at the antenna feed point, and you can put one. Oh no, these answers are not right. Wrong. Those are all wrong. I'm sorry. It should be outside the house near the ground point of the house, is what I meant to say, not the feed point. So the answer is D. I'm sorry, I'm misreading the question. You want a lightning ground arrestor. You want that lightning arrestor tied to ground so that it removes the static buildup or charge, minimizing the chances of a lightning strike. It does not prevent a lightning strike. It will not redirect a lightning strike. It will not protect you from a direct lightning strike. But lightning wants to go not to the most neutral point or ground. It wants to go to the highest oppositely charged location. By dissipating any charge through a lightning arrestor, you won't make your location the place it wants to go. That's the theory, and it generally works. Where should a fuse or circuit breaker be installed on a 120-volt AC power circuit? It should be used in series with the hot, okay? So the answer is A, only in series with the hot. Do not fuse the neutral. What should be done to all external ground rods or earth connections? C, they should all be bonded together with heavy gauge wire or conductive strap. Generally, the National Electrical Code calls for 6 gauge or greater, AGW 6 or greater. What hazard is caused by charging or discharging a battery too quickly? Depending on the battery, but generally you'll overheat it, and that may cause outgassing, but it could also, in the case of lithium batteries, it can make a big boom boom. Don't do it. What hazard exists in power supplies immediately after turning it off? Well, the capacitors can be charged up. So D, stored capacitor filters, or filter capacitors, I should say, they can hold tremendous voltages and they can still be deadly until they're discharged. So, which of the following precautions should be taken when measuring high voltages with a voltmeter? Well, the answer is D, but the way they're written, that answer and the real answer below is confusing. It says D, ensure that the voltmeter is set to the correct frequency. I think somebody miswrote that because the answer down here is correct. Ensure that the voltmeter and leads are rated for the voltages to be measured. If you're measuring 200 volts with a 50 volt meter, you're going to be in a world of hurt. For one thing,
yeah. In our book, that one is B as in boy, but in your sheet, that's D as in David. But it's the same answer.
But the right answer is ensure that the voltage leads are rated for the voltages to be measured, right?
Yeah, in our book it's B for that
Okay.
answer, not D. So
okay, good. Remember, that's the one to go with. Which of the following is a good practice when installing ground wires on a tower for lightning protection? My answer here is C. Ensure that the connections are as short and direct as possible. They just say short and direct. And by the way, they should be as secure, and you should avoid hard bends. You short, avoid hard bends, and as direct as you can possibly make it. When is required? What is required when climbing an antenna tower? I think I covered this last session, didn't I? Okay. If you're going to climb a tower, first you need to have proper training to climb a tower. Don't do so if you don't have it. Don't climb a tower, by the way, if you're afraid of heights. B, use appropriate tie-off points at all times. Anytime someone climbs a tower, they should have a lanyard continuously tied to the tower. So if you climb, that means you need two, because you always move one and the other is to protect you before you fall. Basically move one higher and leave the other one until you get the first one secure up above, then you secure the second one above. Always wear the approved climbing harness. And by the way, you should be properly trained in using climbing harnesses. We're no longer permitted, nor should you ever use a lineman's belt. I have one from my old days. And back when I was a young apprentice and a young electrician, if you fell, a climbing belt would save your life and break your back. Climbing harness will not break your back. You might not survive depending on where your back broke, even though it would stop you from falling to the ground. Under what circumstances is it safe to climb a tower without a helper or observer? And that is never. In fact, generally speaking, the rule of thumb is you should have two. Which of the following is important safety precautions to observe when putting up an antenna tower? My answer here, it says insulate, should look out and stay clear of overhead electrical wires. I'm going to tell you this straight up. Don't put an antenna tower anywhere where it can fall on either an electrical service, power lines, or a residence, because BOCA forbids it. No, it is not legal to strap a tower to your house. BOCA prohibits it. There are straps for attaching towers to buildings. Therefore, buildings that are not residential, like police departments, fire departments, and commercial buildings, provided nobody lives there. What is the purpose of a safety wire through a turnbuckle used to tension guide wires? And it's to prevent the turnbuckle from loosening from vibration. As the turnbuckle or as the guide wire is vibrated in the wind, it prevents it from loosening. What is the minimum safe distance from a power line to allow when installing an antenna? And it's got to be enough so that if the antenna falls, no part of the tower or antenna can come within 10 feet of the power lines. Why 10 feet, everybody? Because high voltage power lines can jump 10 feet. The arc can go 10 feet and get you. Which of the following is an important safety rule to remember when using crank-up towers? The answer is never climb an extended crank-up tower. The tower has to be cranked all the way down, and a blocking mechanism, a safety blocking mechanism, they're specially made for the individual type of tower, that should be locked in place. Generally speaking, the whole purpose of a crank up and crank down tower is so you don't have to climb it. Don't do it. They're never safe to climb on your own. If the tower gives way as you're climbing up, each section inside the other will collapse down, and whatever you're holding on to, the section above it will act as a guillotine and cut your fingers and toes off on its way down. And guess what happens to you? Even if your safety harness and lanyard break your fall, you might bleed out before they get you down. Sound like a good reason not to climb one? Why should you avoid attaching an antenna to a utility pole? And the answer here is C. An antenna could come in contact with the power lines. I don't think the hams haven't done it. They have. The power company will not be friendly with you for it. Which of the following is true when installing grounding conductors used in lightning protection? You got to avoid sharp bends. That's a must do. Lightning will not bend around sharp bends, and so you won't be protected at all. Which of the following establishes ground requirements for amateur radio towers or antennas? B. All towers and antennas over 200 feet require tower lighting and compliance with FAA regulations for distance from an airport. Local codes might have some influence over it, okay, but grounding requirements, I don't really like that answer. All right, their answer is B, the local electrical codes. That's the right answer. I'm sorry, or misread that. No wonder I thought it was wrong. Local electrical codes. Well, local electrical codes usually follow Part 90 or Article 810 of the National Electric Code covers radio and communications installations. The grounding requirements of 810 refer you back to Article 250, grounding and bonding of the National Electric Code. That's several thousand pages of legal gobbledygook. It's hard to understand, and that's why I refer you to the ARRL bonding and grounding and bonding book, because it is normal American human English, a translation from the legalese of the National Electric Code. By the way, electricians and engineers take a year's worth of schooling to interpret the National Electric Code. What type of radiations are radio signals? Well, they're non-ionizing radiation. They're electromagnetic radiation. They're not ionized. Okay. Which of the following frequencies does maximum permissible exposure have the lowest value? Well, it happens to be about 50 megahertz has the lowest value. And there's a chart in your book that goes over that. This is the start of it. That's the end of it. And review that chart, learn it, because you actually have to file a form online when you put up an antenna nowadays that you're compliant with staying within safe RF exposure ranges. How does the allowable power density for an RF safety change if the duty cycle changes from 100% to 50? Well, if your duty cycle is only 50 rather than 100, it reduces by a factor of 2. So, we covered that the other day. It says down below, and this is really it, answer. It's because the duty cycle present is only half or 50% of the cycle. But the signal power can be twice as high and still have the same average power it would be transmitting at 100%. So the factor is in whole numbers, not percentages. Okay. What factor affects RF exposure of people near amateur radio station antenna? The frequency and the power levels affects the RF exposure. The distance of the antenna to the person affects it, and the radiating pattern of the antenna all affect how much exposure will occur. Using the ARRL charts or the online calculators available, you can calculate what's the safe distance to your antenna. And then you have to make your antenna installed in a way that people can't get closer than that. Usually for most frequencies, unless you're operating tremendous power on very short frequencies, it's not going to be a serious problem. Why do exposure limits vary with frequency? The human body absorbs more frequency the higher a frequency is. So that's why higher frequencies require lesser exposure limits or more stringent exposure limits. I mean, you got to get less exposure or keep a further distance away. Which of the following is an acceptable method to determine that your station complies with the FCC RF exposure regulations? Well, you can either calculate using the FCC bulletin and following all of its math to calculate. You can calculate by using the online computer-based modeling programs, the calculators online, which is what B is. You can calculate by measuring field strength with a field strength meter around the antenna. All of the above are acceptable. Most people just use the online calculation based on computer modeling. What hazard is created by touching an antenna during transmission? You'll get some really nasty RF burns sometimes on relatively low power if you touch just the right spot on the antenna. Trust me, I've gotten a third degree burn from RF. It's a circumstance where I was assured everything was all set, ready to go, and it wasn't. And that's my fault because it's your responsibility to double check safety for yourself. Which of the following actions can reduce exposure to RF radiation? Well, relocating the antenna. If it's someplace not safe, move it. Where would you not want an antenna? Right inside your ham shack. Hams do it all the time. It's stupid. You're irradiating yourself. Put them outside. Be safe. How can you make sure your station stays in compliance with RF safety regulations? By reevaluating the station whenever an item of equipment is changed, basically when you change antennas. Why is duty cycle one of the factors that determine safe RF radiation exposure levels? It affects the average exposure to the radiation, to the electromagnetic radiation. Duty cycle controls how much is going out at a time on average. What is defined by duty cycle during the averaging time for RF exposure? A duty cycle is a percentage of time that a transmitter is transmitting versus when it's not. Now, duty cycle is different for different modes because FM always is transmitting 100% duty cycle. AM is always transmitting 100% duty cycle because of the carrier wave. And sideband is only about 40% duty cycle. There's a chart in your book. Be familiar with it so you get a rough idea. How does RF radiation differ from ionizing radiation, radioactivity? All right. RF radiation, it doesn't really have enough energy to cause significant chemical changes in cells and damage DNA like radioactivity does, because radioactivity actually emits particles. The physical particles do more damage quicker. The long-term RF exposure can slowly affect your cells. And that's why we have these regulations. I don't know that I like this answer, but it's the one we have to go by. Who is responsible for ensuring that no person exposed to RF energy above the FCC exposure limits? The answer is you are. If you're the station licensee, it's all on you. And that is the end of our questions and answers.